Hello everyone. Can someone please confirm if you can hear me and see me? Hello. Can someone please confirm? Okay, great. Thanks, Lakshya Sharma. Uh, hello. Okay. Can someone please? Hello. Can someone please? I'm trying to fix a little few things. Okay. I think my video is not visible in the YouTube streaming. Uh, can you guys please give me like 2 minutes? I'll try to fix this. Um, okay, 1 second. Video. Oops. I don't know what to do with this. Yes. I know that video is not showing. Just give me 1 second. Streaming. Display capture. Yes, Manoj. I'm trying to figure out why this is not working. It used to work, but right now it's not working. I have no idea why. I am not an expert in OBS. Okay, those whoever is watching YouTube, I request you to join Unacademy, and from there we can, you can learn. Okay, whoever is watching YouTube, I'm sorry guys, it's not working. The video is not working. Please come to Unacademy. I'll paste the link for Unacademy. Please join that. Right, I hope for Unacademy, please. Alright, I don't want to waste time for the people who joined in Unacademy. Okay, once again, can someone please confirm if you can hear me and see me in Unacademy? Okay, claps, like, I hope that means you guys can hear me and see me. If you guys can't see me or hear me anytime in the middle of the class, just ping me. Okay. So today the class is basics of graphs. So we are going to learn basics of graphs, like introduction. So I am assuming you guys are beginners, or maybe you guys had some experience and you want to revise this topic. So don't expect a lot of complex things from this class. It will be very simple. We'll be dealing with basics, like understanding of the basics and all. So I hope you guys will have some fun today. Okay, so before I start the class, a small introduction of myself. I was ICPC World finalist twice in 2014 and 15. And I worked in Google Mountain View for 3 years from 2017 to 20, and London for 1 year, from 15 to 17, like ending of 15 to first month of 17. So it's, although it's 3 years, it's just 1 year, 2 months or something. I did my bachelor's from IIT Roorkee, I was in electronics and communication. So if you have any questions regarding IIT or Google or ICPC, you can ask me anytime during the class. I'll answer them whenever I find the right time. Okay, let's go into the class. Okay, those whoever is watching in YouTube, please come to Unacademy. My video is not coming from. Uh, my video is not visible from OBS. I don't know why. Okay, there is some system preferences. Oh, wait a minute. Oh, I think I figured out the OBS thing. Just give me 1 second, guys. Thing. Uh, so it's taking a bit of time. I don't know why it's still not showing my. Okay, perfect, perfect. I think it's visible in YouTube as well now. Cool. So I'll give a short introduction. Those who are in YouTube as well. I was ICPC World finalist twice. I worked at Google, and I also did my electronics and communication bachelor's from IIT Roorkee. So if you have questions regarding these as well, you can ask me anytime during the class. I'll try to answer them whenever I find the right time. Okay. So let's go. So what are we doing? I think um, it's pretty straightforward from the name of the class. We are going to learn about the basics of graphs. So please don't expect any advanced theory or problem solving from this. We'll be learning some basics of fundamentals of graphs, like what are graphs, what are vertices, what are edges, what are different types of edges, different types of graphs, the relation between them, how to count, how to look at them, and those kind of things. Okay, so if you are absolute beginner, then this class is perfect for you to learn about graphs. uh, and those who are watching YouTube, I recommend you to come to Unacademy and watch my class there, because at the end of the class there will be some quiz where there will be a live poll. If you want to participate in that poll, then I recommend you to come to Unacademy and participate there. Okay, let's go further. So today we are going to learn about vertices, edges, types of graphs, and there will be quiz. That's what I said right now as well. So going further, okay, before we go into the class, I want to discuss a little regarding a new batch that is launched in Unacademy. It's called Placement 2.0. It is a 4 months batch. It is useful for cracking coding interviews. So if you are someone who is planning to start your preparation regarding coding interviews of product companies, then this is a great place to start. Okay. Now let me make this class full screen. Perfect. Okay, let's go further. So what this is, like, these are our exclusive batches, like Placement 2.0, Vertex, Triumph, and Ascent. These classes are targeted to different audience. So Placement 2.0 is going to start from 23rd of March. These classes have already started, like 15th, 8th, and 4th. So Placement is a 4 months course for exclusively for people who are preparing for placements. It will be like targeting to teach you mastering data structures and algorithms. Okay. So what do you get? So because of these courses, like, there is a structured learning path, and so a lot of people waste around 60% of their time searching for topics to learn, searching for things to learn, searching for problems to learn. So in this course, like everything is already there. Like the path is already like prepared by experts, so you don't have to search for something new. You already have things in place. uh, and it's one subscription and unlimited access to all batches or courses. So there are 4 courses here. It doesn't mean you pay for each course separately. You just pay for one subscription and you have unlimited access for all the batches or courses. And it will help you successfully contest in competitions like ICPC and CodeJam. So the things that you learn in Unacademy are taught by really good people. So uh, it will help you crack these ICPC and CodeJam. So it will also help you crack interviews of top product companies, because the things that you learn they are specifically targeted for those in the placement 2.0 batch. These are exclusively for placement interviews. So it will help you crack those interviews as well. And at the end of the course there will be a CodeChef certification that you will get. So you can use that certificate. It's an industry appreciated certificate. So uh, it helps you a lot. And the subscription fee, if you take a 12 months plan, then the subscription will come down to less than 90 rupees per day. So it's very economical as well in that sense. So, what will you get in each of these courses? You will have live interactive classes. Each class, there will be live polls, quizzes, and question answers during the class. And after the class, practice relevant problems on CodeChef. Like each class comes with a set of curated practice problems to help you apply the concepts in real time. Like you don't have to search for problems after you watch the class. You will get those problems tailored for you. Okay. And there will be doubt support as well. Like there will be a community and there will be expert panel of teaching assistants as well, who will help you answer questions of yours, so that whatever doubts you get, those will be cleared. And this is a 4 months batch. It is starting on 23rd of March. So if you have not taken the subscription, I strongly recommend you to take that. And these are the things that you will learn in that. So from week 1 to 4, first 4 weeks, you will be learning basic data structures, fundamentals, and interview specific problem solving. You will not be taught all the complex segmentaries and all, but interview specific questions will be asked. And you'll also be taught advanced data structures. And then you'll learn string algorithms on week 7. On week 8 you will be learning game theory and greedy algorithms. And 9 to 11, 3 weeks you will be learning dynamic programming, and rest of 4 weeks you will be learning graph algorithms. You will also be solving previous interview problems. So our educators are like really top notch. Like they were been ICPC World finalists, Codeforce's international grandmasters, alumni of top product companies like Flipkart, Amazon, Google, and so on. So these are some of our educators. Uh, so you can read about their description. You can pause the video and look at their description whenever you feel free. They are really top-notch people. These are some more of our educators. So the plans are like this. Like you can take 1 month plan if you're really not sure if you want this or not. And if you want to, like, don't risk much but you want to go further, you can either take 3 months or 6 months plan as well for these prices. And if you really feel this is what you want, and you know that this will help you a lot, and you can go for the 12 months plan. And it costs around 2,750 per month, and like 33,000 divided by 365, it comes to less than 90 rupees per day. So I and you can use the coupon code adurysk, and you will get an additional 10% off, I believe. Let's go. Okay, let's start the class. Give me a second. I'll just drink some water. Okay, basically, what is a graph? Graph is an abstract concept. So it's not like a physical object, right? Like you have cups. There is a cup. There is a dog. Sorry for my drawing skills. So there are dogs, cats, cups, holes. These are all physical things. But graph is an abstract concept where there are vertices. Vertices are also called nodes sometimes. Okay, and there are edges. So there is an edge between these two vertices and these two vertices. We can name the vertices as well. A, B, C, D. And we can name the edges as well. This is edge AB, this is edge BC, this is edge CD, this is edge BD. So this is a graph. Anything anything that we can represent like vertices and edges, that is a graph. Okay, so there are different kinds of edges. Like the edges can be between two nodes. The edge can be from the same node to itself as well. Okay, so this is called a self loop. If there is an edge from it to itself, like AA, so this edge is called a self loop. And if there are no self loops in a graph, then the graph is called a simple graph. If there are no self loops, then the graph is called a simple graph. This is a simple graph. Is this clear? Let's go next. So what are examples of graphs? So the road network that we have in any place, it is a graph. Like for example, there are cities, like there is Delhi, there is a road from Delhi to Hyderabad, and okay, let me color these differently. So there is a node Delhi, there is a node Hyderabad. So there is a road network from Delhi to Hyderabad. Let's say there is Mumbai, and there is Bangalore, and there is Chennai, right? So let's say there are road networks like these. So so this is a graph, simple, right? So the edges are roads and the nodes or vertices are the cities: Delhi, Hyderabad, Chennai, Bangalore, Mumbai. Clear? Any doubts you can post in the chat. I'll try to answer. And what else? Another example of graphs is internet itself, right? So we have many computers in the world, right? So this is me, that is sitting at my computer at my home. This is student. Let's take an example. Someone who just joined, Jayanta maybe. Jayanta's computer. This is Geeta's computer. And let's say this is someone else's computer. Of okay, now all these computers are connected, right? I am teaching from my home, and you guys are listening to this class at your home. Like the information is going from me to you guys, right? So this is internet, like the internet, like you guys are connected like this as well. There are more edges between all of you guys, and there are more other computers in the world, and all of them are connected to all of us, right? So internet is also a graph. Like each computer is a vertex, and all the connections, the wires that are connecting each of our computer is an edge. Okay, I hope the uh, basic understanding of graph is clear to you guys. Okay, someone asked, Ritvika has asked, will it consist of only interview questions or live coding will also be there? So I think you asked this with respect to the placement 2.0 batch. Uh, so I am not sure if there will be live coding session. However, there will be live classes where you can interact with the educator. Like you can ask them questions, you can ask them doubts during the class, and you can ask them to repeat what they are saying if you did not understand during the live class. Okay, and there will be interview questions as well in the placement 2.0 batch, which is going to start in March, on March 23rd. So after the class there will be problems given to you, and you can solve those problems, and you can ask doubts in the community as well. Let's go next. So there are two types of graphs again. So there are directed graphs and there are undirected graphs. There is a question. Jayanta, yes, there will be problem set after the end of each class in the batch. Like I have discussed about a batch that is going to start from March 23rd in the Unacademy. If you take the subscription, you will get access to that course and every other course in Unacademy, and you it's less than 90 rupees per day, so it's very economical as well. So there will be problem set after each class prepared for you. So now let's discuss directed graphs versus undirected graphs. Let's say there is a vertex A and there is a vertex B, and there is a vertex C and there is a vertex D. Same, let's say there is a star, B star, C star, D star. Let's say there are 8 vertices like this, and there are edges between A and B, B and D, C and D, A and C, B and C. Okay, let's circle these for better visibility. So there are 4 vertices and 5 edges. Okay, so this is a undirected graph. Like each edge you can go from A to B, you can also go from B to A. Okay, in the same way, not in the same way, in an opposite way, not opposite as well. So let's say there are 4 vertices in a graph, and there are directed edges. Directed edges, like you can only go from A to B, you cannot go from B to A. So that's called directed graphs. Like each edge has a direction. Like for example, like information, like settings of some group of computers can be an example. Let me think of a better example for this. Uh, let's take the food chain. For example, like animal A can eat animal B, but B cannot eat A. So in the same way, B can eat D, D star can eat C star, C star can eat B star. This way, right? Like there are some rules where one animal can eat others, and not the vice versa. Okay. Okay, there is a question. Will you cover all the topic and algorithms related to graph? Come on, Manish. It's impossible to cover all the topics of graphs in a single lecture. So this class is basically basics of graphs. Like you will understand what are graphs, what are different types of graphs, and at the end there will be some quiz to test how much you understood the concepts and all. It's impossible to cover all the topics and algorithms in a single class. I recommend you come to the next class and later as well. Yes, we will be discussing more algorithms in further classes. Like this is a 3 class mini course that I am taking. Today we are learning basics. Tomorrow there will be breadth first search, and day after tomorrow it will be depth first search. So we'll be discussing different algorithms for those search techniques tomorrow and day after tomorrow. Today is like basics, basic understandings. Okay, so this is for absolute beginners, the targeting. So uh, if you are looking for advanced algorithms in graphs, then I strongly recommend you to follow other courses that were already there in the Unacademy. This one there will be some algorithms tomorrow and day after tomorrow, but today it will be basics. Okay. So I hope you guys understood the concept between directed graphs and undirected graphs. Okay. Now let's go further. What is a click? So basically you understood what is a graph, right? So there are n vertices and m edges, let's say. If each of the vertex is connected to every other vertex, for example, this is a click, the one that I'm drawing right now. Each vertex is connected to other vertex. Okay, this is vertex A, this is vertex B, this is vertex C, this is vertex D. This is called a click. Okay, it is also, there is another notation for this. This is called K4. That means this is a click of size 4. Okay. A question for you. Is this graph a click for 4 vertices A, B, C, D? Is this graph a click? Why? Because some edges are crossing each other. Okay. So for example, if you take this, right? Now all the edges are not non-overlapping. Like this edge, this edge, this edge. Like let's name these vertices as well. A, B, C. I can draw this graph on a paper and no two edges are overlapping. Like for example, if I draw uh, a graph of size 6, okay, now if I connect these two, let's name the vertices as well. A, B, A, B, C, D, E, F. Now, if I want to connect B and D, I can connect like this, right? I can draw an edge like this. Now, if I have to connect C and A, is there any way I can connect C and A without cutting any other edge? Like for example, I can draw an edge between C and E, right? It did not cross any other edge. Yes, we can draw in 3D, but in 2D, can I draw such a edge? Like whatever way I try to draw, right? Like if I go this way, I'm going to cut this edge here. I cannot do it. So I cannot go that way. Okay, I'll use a different color. Let's say I am trying to go this way. If I'm going to this way, it will cut this edge. If I am going this way, it will cut this edge. In the same way, if I am going this way, it will cut this edge. If I am going this way, it will cut this edge. Like whatever way I try to go, I cannot reach A without cutting any other edge. Is this clear? So that's why, like, if there is a edge from A to C, there will always be a cut. There will always be a cut, like here. Right? So that's why this graph is not planar. This graph is called planar. Like if you can draw the graph on a paper where no edge cuts another edge, then that graph is called planar graph. Is this clear? Does anybody want me to repeat this? Cool. I hope this is clear for the people in YouTube as well. I am watching your comments, so if you have any doubts as well, you can comment in the YouTube chat. I'll reply to your comments there. Let's go further. So now we are going to learn about cycles in a graph. What are cycles? So let's say, just give me one moment. It's too cold here, so I had to adjust temperature. Okay, so cycles in a graph are, let me draw a graph. A, B, C, D. Now let's say there is an edge between A and B, B and C, C and D, D and A. Let's say there is also edge like this. Okay, now a cycle is something where you start from a vertex, you go through this edge, you go through this edge, you go through this edge, and you come back to the same vertex. Okay, like you go through edges and you come back to the same vertex. That is called a cycle. Okay, now are there any other cycles in this graph? Can you spot some? Like, can someone spot if there are any other cycles in this graph? So there are other cycles like this. There is a cycle from A to B, B to D, and B to A. Let me use a different color. A to B, B to D, and D to A. This is a cycle. A, B, D. Yes, perfect. Another example is B, D, C. Perfect, perfect. You're doing great, Ritvika. So there is B to D, D to C, and C to B. This is another cycle. And are there any other cycles? I mean, there are other cycles where you go to vertex twice. That's also fine. Let's go further. So, if there is a connected graph, and there are no cycles, then connected graph, like undirected graph, and there are no cycles, that is called a tree. No cycles, oops, no cycles, undirected, and what else did we discuss? Connected. Okay, that is called a tree. Like if there are no cycles, and if it is undirected, and if it is connected, that is called a tree. uh, I'll answer your question, Tirumala Ramana Raju, the one which you posted on YouTube. I got your question. I'll answer after this topic. So, so let's take an example of a tree. Is this a tree? Is this a tree? Is this a tree? No, this is not. Why? Because there is a cycle, right? Let's take a different example. Is this a tree? Are there any cycles? Is it connected? Is it undirected? Right? So this is a tree. So this is an example of a tree. Okay. So there is this nice property of a tree. If you count the number of edges in a tree, it will always be n minus 1, where n is the number of vertices. It will always have n minus 1 edges. You can uh, try to draw a tree with more than n minus 1 edges. You cannot. There will always be a cycle if you draw with more than n minus 1 edges, and if you draw with less than n minus 1 edges, there will always be disconnection, like it will not be connected graph. It will always be having n minus 1 edges. Any tree will be having n minus 1 edges. Okay. I hope this is clear. Okay, I'll come to the question asked by Tirumala. Sorry, I can't spell whole of your name again. Sir, in planar graph, should there be an edge between every two vertices? Not necessary. Like even like suppose I take this. So even this graph is planar. The only defining property of a planar graph is that you can draw it on a paper where no two edges cut each other. That's it. Okay. uh, that is the definition of planar graph. So in this graph, we could not draw it without cutting each other, without cutting two edges. So this way, this is not a planar graph. This graph we could draw without cutting each other. This way is called planar. This is also planar. Okay. I hope it answered your question. Now another, bipartite graphs. Bipartite graphs are those graphs where there are two sets of vertices where the edges are only between left set of vertices to right set of vertices. Okay, this is a bipartite graph. So there is a left partite, there is a right partite or partition, whatever you want to call it. So there is left half and there is a right half, and there are only edges from left half to the right half. Like the examples of this graph can be uh, possible marriage combinations, right? Like this person A, let's say these are guys and these are girls. Let's rule out in intrasex marriages, like guy marrying guy, because it's not still legal in India. So like these are guys like A, B, C, D, E. So this person is interested in all these three persons. Like this is girl, Z, X, Y, W, V. Uh, so guy A is interested in Z, Y, and W. Guy B is interested in these two, and in the same way, girl Z is interested in A and B. So this is an example of a bipartite graph. Okay, um, let's go further. Isomorphism. Isomorphism is where uh, two graphs, even though they are drawn differently, but you can restructure them and you can uh, make them look similar. For example, let's say uh, let me use a different color. Let's say there are four vertices. This is A, B, C, D. Let's say another graph A, B, C, D, or let's call it different, E, F, G, H. Now let's say there are edges like this. Let's say this is called graph G1 and this is graph G2. Now, are these two graphs uh, isomorphs of each other? Like, can you manipulate those graphs and make them look similar? Like, they are. I'll show you how. Like, let's say you rotated the graph 2, you rotated into this fashion. Like, this is E, F, G, H. Like, there was a edge between E and G, there is a graph between E and G, and there is edge between outer edges, right? So even in graph 1 and graph 2, now they look similar, right? Like these don't look similar, but if you rotate graph 2 like in anti-clockwise, then these two look similar, right? So these are called isomorph. So these two graphs are isomorphs of each other. Okay, like if I take a different example, uh, let's say I have a graph like this. Uh, let's name this vertices A, B, CD, and we have a graph like this. No, E, F, G, H. Okay, are these two graphs isomorphs? Are these two graphs isomorphs of each other? Graph G1 and G2. Are these two graphs isomorphs of each other? Like, can you rotate or like transform one graph into other? Is it possible? No, right? So these are not isomorphs. Okay, let's go further. So complementary graphs, complement. So let's take two graphs A, B, C, D. Let's say there are edges like this. Now, what are the edges that are absent? Like, let's name the vertices A, B, C, D. So in this graph, we have AC, we have CD, and we have BD. These edges are there. What are the, let's draw the graph again. Like, let's say A, B, C, D. Now, there is no graph AB. So, sorry, there is no edge AB. So, let's draw AB. There is no edge AD. Let's draw AD. There is no edge CB. Let's draw CB. These two graphs are called complements of each other. This is graph 1. This is graph 2. C, D. Okay, like the edges in graph 1 are absent in graph 2, and the edges of graph 2 are absent in graph 1. So that's why these two graphs are called complements of each other. Okay, if they have exactly same edges, they are called isomorphs of each other, and if they have opposite edges exactly, they are called complements of each other. Okay, let's go further. Okay, now it is quiz time. uh, we'll be answering some questions. Okay. Okay, take this question. Which of the following statements is true? Number of odd degree. Okay, we did not discuss degree. Let me discuss degree. So A, B, C, D. Okay, we are discussing degree. Okay, now let's take a graph A, B, C, D. Let's call this A, let's call this B, let's call this C, let's call this D. Now, the number of edges connected to the node or vertex is called the degree of vertex. Okay, so the degree of A is 1. The degree of B, can anyone tell me the degree of B? Like, the degree of D is 2. It is connected to 2 edges. The C is connected to 2 edges, so the degree of C is also 2. And B is connected to 3 edges, so the degree of B is 3. Okay. So what will be the sum of all the degrees? Okay, here the sum of all the degrees is 1 plus 3 plus 2 plus 2. that is equals to 8. It will be equal to 2 into number of edges, because each of this edge, it is contributing to the degree of both the vertices by 1, right? Because of this edge, the degree of A is increased by 1 and degree of B is increased by 1. So the total sum of degrees of all the vertices will be twice the number of edges of the graph. Okay. Now, uh, okay, we just discussed it, but that's fine. Consider these two statements. Number of odd degree vertices is even. Sum of degrees of all vertices is even. Which of these two statements is true? Those who are in the class, you can answer the poll. There is a live poll. Uh, okay, somebody answered only Q. Okay, so since, okay, we just discussed that the sum of all the degrees is 2 times the number of edges, right? Now, number of odd degree vertices, let's say it is odd. So let's say there are x even degree vertices and there are y odd degree vertices. The parity of sum of all these x vertices will be even, and parity of all these y vertices will be odd. So even plus odd will be equal to odd. But this is wrong, right? Sum of all degrees is even, so there cannot be an odd number of odd degree vertices. Oh, right. So number of odd degree vertices should be even. So answer is C. Both P and Q are correct. Let G be a complete undirected graph of 6 vertices. If vertices of G are labeled, then the number of distinct cycles of length 4 in G is equal to. Okay, this is a big question. I'll try to draw the graph. Let's say there is a complete undirected graph of 6 vertices. 4, 5, 6. Okay, it is complete undirected. So this, 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 okay, I hope this is a complete undirected graph. Okay, this is a complete undirected graph of 6 vertices, and each vertex is labeled as well: A, B, C, D, E, F. Okay, now we want to find number of distinct cycles of length 4. Okay, uh, hmm, okay, uh, okay, I'll create an option E as well. None of the above. try to solve this question. I actually forgot the answer. I'm trying to calculate it again. So okay, try to count the number of cycles of length 4. Those who just joined, the question is as follows. Let G be a complete graph of 6 vertices. Number of cycles, distinct cycles. So the cycle A, B, C, D, and the cycle A, D, C, B. Both of these are same. Like A, B, C, D to A, and the cycle A, D, C, B, A. Both of these cycles are same. Okay, so I'll give one more minute to solve this. Actually, it will more than one more minute to solve this. Try to solve this. This is a very interesting question on permutations and combinations. Okay, nobody could answer the question. Maybe it's too hard. So the answer is 45. Let us see how. Number of. Okay, I'll do it in new slide. How many ways can we select 4 vertices? Out of 6 vertices, we can select 4 vertices in 6 choose 4 ways, right? That is equals to 6 into 5 into 4 into 3 divided by 4 into 3 into 2 into 1. So this comes out to be 15. Number of ways of selecting 4 vertices, it is 15. Now that we have 4 vertices, let's call them P, Q, R, S. The number of ways we can have cycles between these 4 vertices, it will be it will actually be 3. I'll give you this as a homework to do it by yourself. So the product of these two is 15 into 3, that equals to 45. Okay. Is click of a size 4 planar? This is click of size 4. Is this planar? Is click of size 4 planar? Okay, somebody mentioned it is false. No, it is planar. Why? Because you can redraw this, right? Let's say this. Now, whatever, like A, B, C, D, whatever the edge between A and C is, you can draw it like this as well, right? Without cutting any other edge. That's why this is planar. Click of size 4 is planar because you can redraw that edge uh, to make it planar. Is click of size 5 planar? Like, can you rearrange these edges in a way where they don't intersect each other? Is click of size 5 planar? Like, can you rearrange these edges? The poll is going to end in 6 seconds. No, it is not planar. Like, whatever way you try to rearrange this 5 size graph, it will not be planar. Okay, read this statement. No two vertices have the same degree. At least two vertices have the same degree. At least three vertices have the same degree. None of the above. Like any graph, if there are n vertices, and at least n minus there are at least n minus 1 edges, it is a connected graph. Now, which of these statements is true? Like there are n vertices and m edges, and it is a simple graph. There are no self loops. Uh, what is the uh, which of these follows statements is true? No two vertices have the same degree. At least two vertices have same degree. At least three vertices have same degree. None of the above. It is a simple connected undirected graph. Those who are watching on YouTube, I strongly recommend you come to Unacademy and answer the poll here, so that you can participate in the poll, and it will be fun. Okay, the answer for this is at least two vertices have same degree. The reason for this is, since it is an undirected connected graph and it's a simple graph, the degree of each vertex will be at least 1. And the maximum degree that a vertex can have is n minus 1. It is connected to all the n minus 1 vertices, right? So it can either have 1, 2, 3, so on up to n minus 1. Right? Now, how many vertices do we have? N. Now, if we apply pigeonhole principle, at least two vertices will have same degree, because there are only n minus 1 distinct number of degrees a vertex can have. That's why at least two vertices should have same degree if there are n vertices. Okay, so option B is correct. The maximum number of edges in a bipartite graph of 12 vertices is, so let's say there is a bipartite graph. There are x vertices in the left partite and y vertices in the right partite, and x plus y is equals to 12. What is the maximum number of edges possible? So there is a quiz going on, those who just joined in YouTube. Uh, so let's say there is a bipartite graph with 12 vertices. Left partite has x vertices and right partite has y vertices. X plus y is equal to 12. Uh, what is the maximum number of edges that the graph can have? Perfect. Suraj has answered the question correctly. So I'll end the poll since Suraj has answered this question. For those who are watching YouTube, the answer is as follows. The number of edges with x vertices in the left and y vertices in y is equal to x into y, right? E is equal to x into y. This is the possible combinations are 1 into 11, 2 into 10, 3 into 9, 4 into 8, 5 into 7, 6 into 6. Out of all this, 6 into 6, 36 is the maximum. So option A is the right answer. Which of the following graphs is not planar? Which of the following graphs is not planar? G1, G2, G3, G4. If it's not visible, I'll write down again. This is G1, this is G2, this is G3, this is G4. Okay, Suraj could not answer this question. The answer is, let's try to solve each one by one. G2 is already planar, like no edge is intersecting no other edge, right? So let's try to take a look at G3. G3, what we can do, let's take this edge, we can draw from outside like this, right? So how will the graph look like? So this edge we have drawn from outside. Okay. Now this is planar. So G3 is also planar. G2 is also planar. Now we have to decide between G4 and G1. Now G4, let's name these vertices A, B, C, D, E. Now G4 is also planar. I'll draw how? A, B, C. I'm sorry, guys. Um, so A, B, C, D, E. Now there is a edge between C and E, right? Like let's draw it from outside. Okay. Now the edge between B and E as well. Let's draw it from outside. And B, okay, B and D we drew it from outside. Now there is an edge between A and D. C and D is also drawn. B and D is also drawn. Perfect. I drew it perfectly. uh, Leaving the self praise aside, we can draw graph G4 as well as a planar graph without no two edges intersecting. Okay. Like you can verify AB is there, AB is there, BC, BC. Let's count the number of edges. That's sufficient probably. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So you can verify the answer. It is a planar graph. Now graph G1 unfortunately cannot be a planar graph whatever way you draw. Okay. And isomorphism can be proved between graph G and graph B if their complements are isomorphic. True or false? Perfect. Suraj got it right. Uh, yes, if if the complements, if two graph T and B are isomorphic, then their complements will also be isomorphic. Does anybody have any questions? If you have any questions regarding today's class, or I worked at Google for 4 years. If you have any questions regarding Google, I went to ICPC World Finals twice. If you have any questions regarding that, I studied at IT Roorkee. If you have any questions regarding that, you can ask me. I'll try to answer your questions as much as possible. Uh, if you guys have any questions, you can ask me, or else we can end this session. Okay. Uh, there is a question from Suraj. Being from electronics branch, how did you manage to get perfect at DSA? Okay, so there is no such thing as perfect, Suraj. So um, I was in electronics branch. True. The things that are taught in our college are very basic. Like we had a data structures course in our college, but it was very basic. The thing that driven me to become better at DSA is through competitive programming. I used to uh, compete a lot in online contests, so watching other people perform, learn from them, competing with them, that adrenaline rush drove me to get better in all the topics, in whatever topic that was there in competitive programming. So I would say, like, I mean, the branch wouldn't matter. The things that you learn in college don't matter so much. Like the branch which you are in doesn't matter. Whatever branch you are, like there is so much help online available. There is so much content that is available online. So you can learn from a lot of people online. Like Unacademy is one place, one really good place where you can learn from. So nothing can stop you if you have motivation and will. Okay, so I hope that answered your question. Mohammed Saif Ali is asking, I'm in tier 3 college first year, what should I do? Great question, Mohammed. uh, so in like right now in this internet era, it doesn't really matter if you are a tier 3 college student or tier 1 college student. Okay, it really doesn't. Like in internet you can get access to a lot of information. Okay, if you really have determination to study, you can get the information and you can get the content and you can learn. So participate in contests. Like there are so many online contests going on, like CodeChef, Code Forces, Top Coder. So many contests every week they are going on. So participate in those contests. Try, like, even if you can't solve even one problem, still try to give an attempt and read the solutions at the end, like editorials at the end of the contest, and try to learn from them. Set a goal, set an inspiration, and don't worry about results. Just learn about the things that interest you. Even if you set goals, don't panic too much if you don't reach those goals. It's okay. Life is not just competitive programming. So I suggest you learn as much as possible in first year. Like don't like you don't have to set any goals in first year, since you are beginning. Like one thing I would recommend is like joining an academy subscription, and there you can, like, there are many beginner courses that are available. So you can join the subscription and learn the all the topics without wasting time on searching for things. Okay, so we have other question. After what rating at CodeChef should we start Code Forces contest? It doesn't matter, Dave. It really doesn't. Like, you can start right away today. Like I think there is a contest running in Code Forces right now. You should just go and start it right now. There is no time. It's nothing like you should reach this rating and then go to Code Forces. Even in Code Forces, there is due to, and there are basic questions even in Code Forces. So if you're absolute beginner as well, it shouldn't matter. You should just go and compete there. So yeah, in Code Forces there are many short contests. So in CodeChef there are long contests and short contests. So that's why I like you should try to do both. There are benefits of both long and short contests. So I recommend you doing both. Okay, another question from Ritvika. Uh, can you tell as a okay no product based companies don't come in my college. How do apply for them? Are they too difficult than campus ones? Please answer. uh, Good question, Ritvika. So if product companies are not coming to your college, then one way would be applying to them through a referral. Like if you know someone who is working at that college, sorry, that company, and that person can refer you, that will be a great thing. I believe there are also placement contests in CodeChef, Codeforces, Hacker Earth, so many places, right? Like if you perform good in those contests, then you will get directly into interviews of those companies, right? So that is one option that you can do. Growing your network is the other. Like knowing people will definitely help you. Getting some good credentials in competitive programming will also help you. Like suppose if you become a red coder in Codeforces or 7-star coder in CodeChef, then people will look up to you. Like people like will message you directly. Like so um, that's one way. Like get like performing really good in these competitions, attending these placement drive competitions, and knowing people will help you get into these product companies. So one thing I suggest to you is don't lose hope. It doesn't matter if you're in a low college right now or tier 3 college right now. If you keep working towards what is interesting to you, you will definitely get into a product based company someday. Okay, so don't lose hope. Just do whatever you are interested. If it is giving you some happiness, then it's perfect. Like that's very great. So I hope that answered your question. Okay, another question from. Okay, let's take one from YouTube. Just cause code forces are generally tougher contests than don't reward as much for beginners. Oh, is it? The div 2 A and B are usually very simple, right, Dave? Uh, I don't know. Div 1 is usually harder, but Div 2A should be easier. Like I think maybe you already had that mindset that code forces is hard. That's why maybe you're finding it hard. I am not sure. Usually Div 2A and B are solvable by most beginners. So like if you are like even if you spend like 1 or 2 weeks, then you should probably solve div 2a and div 2b. uh, if not, then you should look at why you are not able to solve. I think you should be able to learn them quickly as well. Okay, let's take a question from Suraj. Can you tell us briefly how you cracked tech giant Google and how did you prepare for it? Okay, it's a short story. Like I participated in a contest called APAC, APAC, Asia Pacific, some contest. I got a good rank there. And I also had a friend working at Google who referred me. So after these two feats, like I got a call for interview. I flew to Bangalore, and there were 4 interviews. I could perform good in those interviews by God's grace, and that's why I got select. That's how I got selected into Google. Let's. There is a continuation question from Ritvika, but I don't have so much time to get to 7 stars in code forces. I am already third year now. Yeah, I just gave it as an example. You don't have to become red in code forces or 7 star in CodeChef. However, so that's why I said there are product recruiting competitions as well, right? In CodeChef and HackerRank and Hacker Earth. So if you perform good in those competitions as well, you can catch the eye of those recruiters. So, like one way would be that, and uh, don't lose hope. Like even if you are in third year of your college, it doesn't really matter in long term, right? Let's say after 10 years from now, if you keep working towards improving your software engineering skills and improving your competitive programming skills, like maybe you can get a job after 5 years, right? Like it doesn't matter, like it doesn't matter if you don't get a job just out of college, right? So don't take too much pressure that you have to get a job after college because everybody of like many of your friends are getting. It doesn't really matter, Ritvika. Like don't take so much stress. Like our culture, our society has made it so competitive that people are chasing things constantly and they want to get results as soon as possible. They want to be better than others. It doesn't really matter in long run. Like like if you can't get it in 2 years, take 4 years, take 5 years. Like unless it is something uh, like you need that job for some basic needs, like you have some personal reasons, then it can be a valid reason to put like efforts more and try to get it as soon as possible. But a better way would be like relax a bit, like step back a bit, think what you're doing, like become aware of what you're doing. Are you interested in what you're doing? uh, and is it meaningful to you? Then put efforts in that direction. In the long run you will get deserving rewards. So don't worry about rewards. Like here, getting a job is a reward, so don't worry too much about rewards. Just keep doing what you like. In the long run you will get what you want. It became a bit philosophical, sorry, but I would say like a concrete suggestion would be like target these product based recruitment competitions that are there and keep working towards your uh, whatever you like. All right, I think we came towards the end. It's already 8:30. Thank you so much, guys. I enjoyed taking today's class. Uh, I hope you guys come tomorrow to Breadth First Search class. We'll be teaching more stuff there and have more fun. All right, tada, bye bye.